Alright students, in this video we're going to be going over the core concept for Math 3, Section 2.1. The core concept is called parent functions. Now, parent functions doesn't just refer to these. There's a lot of parent functions. And the idea here we're trying to establish is, if it's a constant function, it will always be flat. If it's a linear function, it'll always be a straight line, no curve, straight line, but it won't be flat necessarily. It'll be tilted, and that's also what we call slope. Absolute value will look like you chopped this one and pasted it up here, and so it looks like two linears together. Okay, so what these all have in common is they're all very straight on the sides. Once you jump over here, once you put an exponent on there, sorry about that. Once you put an exponent on it, it's no longer a straight line. That's what we want to establish, and that's what we want to just try and figure out. And so I'm going to do a table of values for these in case if you've forgotten how we establish all these different things. It's been a while. Let's get to it. So for my Math 3 students, you might want to write this down in your notebook. If you have a really good notebook for Math 2 or Math 1, you might have some of this information already in there. Okay. So let's open it up, and let's talk about the constant function. First of all, they call it f of x equals x. Sorry. Constant is equal to a number. They use the 1. So let's establish this. X and f of x. And again, f of x is the same as y. Okay. Fx is the same as y. So if you don't like it, you can change it to y equals. That's what my teacher used to let us do, and it really helped me. If you don't like it, you can also call it frank. If that seems less formal, call it frank. It's called, f stands for it's a function, but we can also use g. It could be g of x, it could be any letter. Just want to mention that. The whole idea here is x is the input, and you're going to input numbers into here. 0, 1, 2, 3, 4, 5. So when you plug in a 0, well, there's nowhere to plug 0 in over here. There's no x. Your output is going to be 1. Plug in a 1 function, f of 1, when you plug it in, there is no 1 over here. There's no way to plug in over here, so it's equal to 1. 2, there's no way to plug in a 2. It's going to equal 1, 1, 1, 1, 1. There is no x to plug in here. Your function will always be equal to 1. In terms of the graph, you always want to make your graphs nice and straight, especially the x and y axis. That's critical, very important. Now this would be 1, 2, 3. That could be. All right. 0, 1, right here. 1, 1, right there. 2, 1 is right there. 3, 1 is right there. 4, 1. And while you're watching this video, pause it, of course, if you're still taking notes. Now, well, hold on. Yeah, that's the advantage of doing it this way. If you miss it in class, this will help. So that's a flat line. It is constant because it does not change. It is constantly 1. All right, so let's slide it up, and let's go over the linear one. Now, the linear example they gave with f of x equals x. That, if it doesn't look familiar, let me put it this way. I guarantee you've graphed those. If you've taken Math 1 or Math 2, I guarantee you've graphed those, and we're still going to graph more of them. Straight line equations are really, really useful. Slope is incredibly useful. Even in calculus, you'll be graphing crazy, complicated curves, but you'll analyze the slope of the curve at certain points. So what I'm going to do is I'm going to go with this one. And again, it could be f of x equals 2x plus 5. It's the same as y. Now I'm going to look at my table of values here. And for this one, I'll still use, actually, let's go ahead and I'll use a couple negatives, just so we can see. -2, -1, 0, 1. And so one of the questions that comes up, students ask, how many numbers do I need to do? And technically, just a couple will work. Technically, with a straight line, you can get away with 2, but the more points you use, the more accurate you're going to be. The other thing is, if you make a mistake with one of them, if you do a whole bunch of them, you'll notice that one's wrong when they don't match the rest. So, it's good to know, it's good to practice. Again, the whole idea is f of -2 means take this function, and instead of x, we're going to put in -2. And then we simplify this. 2 times -2 is -4 plus 1, which gives us -3. Okay, so -2, -3 is 1 point. We plug in -1. I'll go ahead and let you do the rest of those. Go ahead and pause the video right now and see if you get the rest, and I'll fill them in as well. So if you plug in -1, you should end up with a -1. If you plug in 0, you should get a 1. Plug in 1, you should get a 3. Now, for a lot of times, if you do not need to write all this out, but if you weren't sure about this f of x notation, it's good to write it out and see what it actually means. Okay? If you're able to plug it in, you know the answers, that's fine for your table of values. A completed table of values, in fact, would probably, if I was going to rewrite it, just go -2 and -3. That's 1 point. -1, -1, 0, 1, and 1, 3. That's a shortened version of it. Okay? But for your notes and stuff like that, I think it's important to write it out, because if you look back at this, you know, wait, how did I get from here to here? Well, this shows all the steps. Okay. I'm going to flip papers, and I'm going to graph it. So go ahead and take a second right now. Go ahead and pause the video. Go ahead and graph it. We should verify that this is linear. Okay, so I went ahead and plotted my points. A couple things I want to point out here. I don't have graph paper, but you're really going to want graph paper. In fact, you might want to buy a graph paper notebook. It costs a little more to get in a notebook form, but it's really good to have graph paper. Yeah, so just FYI. If you don't, just make sure you make it nice and straight. My x-axis is nice and straight. My y-axis is nice and straight. And the other thing, my spacing wasn't even. That spacing was way too far off. And so you can see my points a little off. 1 should have been there. 2 should have been more right there. So if you're accurate, graph paper will solve that problem. But if you're accurate, this should come out looking like a straight line. Okay? So, and that, again, that is linear. Okay? That is a linear function. And again, anything of 2x plus 1, 1/2 x plus 3, 0.5x minus 1, all of those are going to be linear because it's just an x. There's no exponent, there's no fancy stuff, there's no square roots, all that. Just quick side note since we're talking about that. If it's linear, there's also non-linear. That'd be square roots, x squared, x cubed, x to the 4th, and so on and so on and so on. Once you do anything funky like this, it's no longer going to be a nice straight line. Okay? So this is Math 1. This is where we're going with all our Math 3 stuff. We're going to graph all these things and know them very well. Now, it's not overwhelming either. Okay? This, like we said, we're in the family of functions. This is from the radical family. This is from the cubic family. You don't know those families yet, but once you do, it'll be just as easy for you as linear. You'll look at it and you'll have an idea of what it looks like. That's the idea behind the family of functions, being able to recognize stuff without making the whole table of values. All right, let's flip to the next one. All right, you may recognize absolute value as that thing that turns everything positive. Well, absolute value, actually, there's a lot of reasons why you would use that. It doesn't come up too much, but it's good to know what the graph looks like. And if you recognize it, you can save yourself some time. So let me go ahead and make a table of values. And my table of values, I included negatives this time. That's going to be really important this time. Now, if you're thinking, well, doesn't absolute value turn everything positive? Yes. F of -2 would mean plug in -2 inside there, which would just turn it to a +2. And when you plug in -1, it would turn to +1. 0 would still be 0. Now here's the deal. 1, if it's already positive, it stays positive. 2 would stay positive. So because it goes positive, then 0, and then positive again, that's kind of weird, and that's what gives it its shape. Okay. So I encourage you to pause it right now and set up your graph, and then we'll check. Okay, so I graphed all the points here. -2, 2, -2, and then up 2. That's right there. And you can verify the rest of the points. But take a look. It has that type of shape, and that's kind of unique, but it's good to know, and that's how you can create a V-shaped graph. Quick side note, another reason we want to know all these, once we start using Desmos, we can use it to draw pictures and do animations, and the bigger your library of function is, the more curves you can get. What I mean is, when Math 1 does the project, they can only use straight lines, because that's all they know at that point. For you guys, you'll be able to use curves, circles, ellipses, all kinds of stuff. And that gives a lot more range of motion, a lot more shape, a lot more variety, a lot more depth, everything. Okay? And it's kind of like with vocabulary. If all you had was your elementary school vocabulary, the books you read couldn't be very complex. The speeches you give couldn't be very complex. So the more equations we have, the more our understanding of math and the more our understanding of the universe actually starts to increase. And that's what I'm going to try and show you. But we're getting ahead of ourselves. Let's finish this up with the quadratic. So a quadratic function is basically any one that has x squared as its highest power. Now, a couple things I want to mention about that. If it's x squared, it could also be like 1/2 x squared plus 1. It could also be 1/3 x squared minus 3. We could put the x minus 3 inside of parentheses, because it still would, if you FOIL this out, if you multiply it out, you'd have x squared again, and so on. So yeah, as long as x squared is your highest power, even if you have like 1/2 x squared plus x plus 1, well, even though there's an x, because there's an x squared, it's going to be a quadratic. What does that tell you? That tells us that roughly we're going to have that shape. This is one of the most common and most popular ones. And if you want to see a quadratic, here's what you do. If you turn on a hose, when the water comes out the hose, it'll follow the shape of a parabola. If you throw a basketball, throw a baseball, throw a football, throw anything, it will follow the shape of a parabola. Okay? Rockets fired into the sky, if they came back down again, would come back down. Well, actually, sorry, anything launched with rockets are a different case. But we'll talk about this a little bit more. The main thing is, a lot of things that go up and go down will actually follow a curved path called a parabola. So let's get back to it. Let's go make your table of values. And again, let's do the same negatives and positives we did last time. So voila, there's my table of values. Go ahead and pause it right here and go ahead and take a second to fill this in. Okay? I'll set up the first one for you, f of -2. When you do this, be careful. If you type this on your calculator, that's not what you really mean. The calculator will give you the wrong answer for that. What you're doing, we really need to plug in for the x. Okay, what I mean is, it's -2 squared. The calculator would treat it differently otherwise. So you should get a positive 4 out of this. That's the whole thing that gives us our shape. When we plug -1 squared, it becomes positive 1. 0 becomes 0. Now, positive 1 will stay positive, and positive 2 will stay 4. Okay? Now, take a look at this. When we put 3 in here, if we went down, we'd get 9. And here's where you're going to see what's happening with the graph. It jumped by 1. It jumped by 3. It jumped by 5. That's why it's not linear. It is not a constant function. This one's going by constant. It's going 1 plus 1 plus 1. But this side is not increasing by 1. Or basically, it's not increasing constantly. If this is plus 1 plus 1 plus 1, or plus 5 plus 5 plus 5, if the other side does a constant, then it's going to be linear, usually. Okay? This one is not. This one is clearly jumping up too fast. That's what's going to give it its curved nature. So you don't always have to do a table of values, but it's good to know why it does what it does. So take a second, pause the video and graph those, and we'll take a look if we agree. And again, if you don't have graph paper, it really does help. Just try to make them a little bit, the spacing even. I'm doing 1 centimeter each time here. Your graphs will come out a lot straighter. Okay? And that's going to be important. The better you do it, the better you'll learn it, the less you'll have to study for quizzes and stuff. So 2 went all the way up to 4. 3 went all the way up to 9. So the key thing here is if you try to connect this, there's a straight line there, there's a straight line there. Don't do that. It doesn't do that. It constantly curves, and that's the beauty of this thing. It's constantly curving, just like that. Okay. I'm going to go in the negative direction. Two was 4. No, 2 was 4 up here. That's wrong. There it goes. And it takes some practice to get that curve nice and smooth like that. So in the other videos, we'll go over some of the homework questions. But the idea is that even if they put 1/2 x squared plus 1, the method is still the same. The idea here is you know it's going to be the formula, the function is quadratic. The shape will be a parabola. So we call the shape a parabola. We refer to the function as a quadratic. All right. If you're going to do the table values here, you just have to remember your order of operations. Do you multiply? Do you add these? Do you do the exponent first? Well, order of operations goes like this. Got to do parentheses first. Well, there's nothing to do. So the key thing is exponents come before multiplication. Always. Okay? So you have to do the 3 squared first. Always. So 3 squared would be 9, and then plus 1. Then it's 1/2 times 9, which is 4.5, plus 1. And again, you don't do addition because you always multiply way before you get to addition. So that's why you multiply here, and then you get 5.5. Okay. It's good to have a calculator for this. My calculator actually has a fraction button, so I'd go 1, fraction 2, parentheses, 3, parentheses, squared. There's that button for the squared. You can use the up arrow. Or there's a squared button. Go back. Use a squared button maybe. And then plus 1. And I better get, gives me 5.5. So it's a little bit weird to read that one if you're not used to this type of calculator notation. Let's see, hit it again. Oh yeah, it changes to 5.5. There you go. The fraction button is nice to have. It'll go from decimal back to fraction. So it's neat to have. Alright, there you go. Now you know how to do some of them, and the next video will go over specific homework questions. Thanks for watching.